Hi, this is Andrew, aka Beer is Good on Reddit, and today I want to go over some Newton's second law problems. And Newton's full second law is that the force equals the time rate of change of momentum, which means that if we have a change in mass and change in velocity, we're going to end up with the time rate of change of the mass times the velocity times the mass, or plus the mass times acceleration. That's just from doing chain rule on this term right here. Most FE problems, they won't have a change in mass, so ddt of m of the mass equals 0. So we're left with F equals ma, which is what we're used to seeing, and which is what we're going to do in this example problem. So we have this crate, and it's 100 pounds, and the degree is 20. The incline is 20 degrees. Our static friction is 0.2, and our kinetic friction is 0.15. So it's less than the static friction. And we want to know what the velocity is at t equals 1 second. So after 1 second, what's the velocity of the block? So the first thing we want to do is set up sum of the forces. So sum of the forces in the x direction. Well, let's draw a free body diagram first. So a free body diagram on the block. I'm going to draw it like this. So we have our weight force going down. We have a friction force, which is going opposite the direction of motion. That's F. That's W. And the normal force, which is perpendicular to the surface. Normal to the surface, I should say. And we're going to draw our axes such that it's in the direction of motion. So that's x, that's y. And the reason we do this is because we don't want to be left with an x direction acceleration and a y direction acceleration, and then we have to do Pythagorean theorem to get the acceleration in the direction of the surface. We can just set up our axes such that the x direction is in line with the surface, so we don't have to deal with that. So from here we can see that our sum of the forces in the x direction is equal to 0, or we need to set it to 0 first. It's going to be ma, but we need to set it to 0 first. And so we have the weight force times the sine of 20 degrees minus the friction. Right. And the sum of the forces in the y direction is equal to 0, is equal to the normal force, which is same direction as the y. I know I didn't draw it like that, but it's going to be the same as the y direction because this is a right angle. So the normal force minus the weight cosine of 20 degrees. So this angle right here, that angle is 20 degrees. So we need to figure out what the maximum friction force, the maximum static friction. We need to solve for the friction force and see if our static friction can support that. So the friction force in this system is F equals W sine of 20, where W is 100, That's the weight. So the friction force is 34.2 pounds. And we can solve for some of the forces in the y in the same way. The normal force is 100 is W times cosine of 20, which is 94.0 pounds. Okay. So our required static friction force, it needs to be at least 34.2, or else the block will slip. So the required friction, Fs, is equal to the static friction coefficient times the normal force, which is equal to 0.2 times 94.0, and that comes out to be 18.8 pounds. Okay, so since 18.8 is less than 34.2, the block will slip along the surface. If this number was greater than 34.2, the block would stay stationary on the surface. So now we need to find, we need to apply Newton's second law. So in this, at first we did sum of the forces equals 0. Now we need to do sum of the forces equals ma, because the system is actually moving. So sum of the forces in the x direction is equal to ma, which is equal to W sine 20 minus the friction force. With the friction force, now we know it. Now we know that it is the system is moving. We know that the friction force needs to be mu k n, which is the kinetic friction coefficient times the normal force. Remember that in general F equals mu n. So we can solve for ax. Sorry, W sine of 20. So ax is equal to W sine of 20 minus mu kn over the mass. The mass of the crate is the weight over acceleration of gravity, which is 100 pounds over 32.2 feet per second squared, because this is English units and not SI. So the weight is, or the mass is 3.11 slugs. So the acceleration of the crate, ax. Now we can just plug it. Now we can plug everything into the equation, and ax comes out to be 6.47 feet per second squared. Okay, so now from one of our kinematics equations, we know that ax or a equals dv dt, which is equal to 6.47 feet per second squared. So our if we integrate, we have a dt equals dv, separation of variables. Integrate both sides from 0 to v and from 0 to 1, and we get v is equal to AT at t equals 1. So V equals 6.47 feet per second. Okay, so I hope that this video was a pretty good introduction to 2D kinematics and 2D kinematics and F equals ma problem. And I will see you shortly in another video.